But before that we have to check the same curve, this time for passing sight distance. For stopping sight distance, okay, we have just done it. Now how about for passing? Directly you can use the AASHTO table again. For 60 kilometers an hour design speed, it recommends 180 meters of sight distance for passing required. So for L is bigger than passing sight distance, we use this formula, which produces 78.8 meters. So is 78.8 meters indeed smaller, bigger than 180? No, so we reject that. The second situation, L is smaller than passing sight distance, use this formula instead. Minus, reject that. So for passing, we can't use these equations, then we have to look at the AASHTO table. For convenience, it's for 60 kilometers an hour design speed, 38 K value, which we haven't discussed this in class yet. K is a coefficient that needs to be multiplied by the algebraic difference of the grades, in other words capital A. So in my case, 38 times 2.09, that is A, capital A, which gives me 79.4. So therefore the length of my summit curve has to be minimum 79.4. For my project reason, for demonstration reasons, I chose the length as 100 meters. So I have two curves in my project: a SAG type curve which has 150 meters length, and the second curve is a summit curve, and it is 100 meters in length. The next step is to calculate the elevations of these curves, starting from the beginning of these curves, as we did in examples in class. So you may use an Excel spreadsheet for that purpose. Let me show you that. This was the formula, you remember, this was the formula. This y distance equals this times x squared plus g1 times x. Here L, the length of the curve, we've just calculated for both curves in my case. G1, G2 are the slopes of both arms. X is the distance from the beginning of the curve. So for every 25 meters, it's very easy to produce y values using this formula. So you can use Excel to do that. In my case, I have done actually that for example, the beginning of the curve. It's cross section number 6, 57.68. Let me increase the size. H2, another cross section, 58.30 is the elevation. 7, PI1, the point of intersection of the first curve. 8, 9, H3, and the end of the curve. So for these elevations, I have to go to AutoCAD and then show. Let me show you only one example here. Let's 6, for example, cross section number 6, 57.68. 57.68. 57.68, cross section number 6. Here, cross section number 6. First of all, draw a line to see when the ortho is on, to see where this point is. Okay. From this, this is the elevation 53. Okay, 53. So it was 57.68. 57.68 minus 53 is my datum line. Okay, 4.68 8 meters in real life times 5, 23.4. If I zoom in, you can see there is this much of height difference between my straight and the curve. Okay, let's do the next one, another example. Go back to Excel, H2 5830. minus 53 meters times 5, 26.5. I multiply by 5 because I'm working on 1 to 200 scale in the vertical axis. Okay, so I have this much of difference. So in my next video you will see a curve here. By joining these the tops of these lines using polyline, the top of this line to the top of that line to the top of next line, etc. Then it will be my curve. So and I need to do the same thing for the summit curve as well. Same formula, same vertical curve formula, and it will produce the elevations. You can use, as I said, you can use Microsoft Excel for that. So let me pause here for a while and then update my table, my profile drawing, and then in the next session you will see the progress. And before that, before I forget, you have to update these as well. So you can, what you can do is you can delete these lines, then copy this here, again copy, and then type in the correct elevation from Excel file, and then repeat this action for every blank cross section corresponding to the curves. Okay, I have updated these numbers for demonstration purposes. Again, these are in blue color just to indicate that these are actually curve. These are the elevations of the curve. The red ones are the elevations of the straight sections. Okay, my first curve is a sag type curve. Length is 150 meters, and the second curve is a summit type curve. This one here, this one, and the length is 100 meters, and these are the elevations of the curve. This is the beginning station, the beginning of the curve, station 50397. This is the end of my summit curve. This is the beginning of my sag curve. This is the end of my sag curve. The scales, don't forget, is going to be 1 to 200 and 1 to 2000. I need to update that as well. Also, there is one more thing to do, is to add some curve information and at the top for both curves here that I will show you in a minute. Okay, so these are the curve information. Here we have a flag like that, okay, and the point of intersection of this vertical curve in kilometers is 0.241. The station of this point. Elevation of that point